Hi there, welcome to this introduction to electrolysis. This is the first lesson in the fourth year scheme of work electrolysis block. And we're going to introduce some of the key terms, some of the key ideas that we'll need for electrolysis before moving on to molten, then aqueous and industrial electrolysis. So without any further ado, let's remove me from the screen and let's focus on the chemistry. So, before we start on talking what electrolysis is, we're going to start talking about electricity. So, what is electricity? Electricity is the presence and/or flow of electric charge, and the charge is carried by different particles in the different substances. And here we go, we've got four different substances here, and we're going to think about what particles are actually carrying the charge. All four of these will be using or coming across in the topic of electrolysis. So let's have a quick look through them. Copper wires, of course, will be joining the power packs and the electrodes. Aqueous ionic compound, we might be actually doing electrolysis on the aqueous ionic compound, maybe some salt, sodium chloride dissolved in water. And the graphite electrodes, those are going to be the items we'll be putting into the aqueous ionic compound, or indeed the molten ionic compound, i.e. an ionic compound that we've heated up and melted. So think back to the structure and bonding topic, which will be helpful in answering this question. What is the type of structure and bonding present in those substances, and hence what is carrying the charge? Why don't you pause the video now, think about that, and then we'll carry on. Okay, so let's think about the charge carriers in each of these four substances. First of all, copper wires. Copper, of course, has metallic bonding, i.e. the copper has a lattice of positive metal ions surrounded by a sea of delocalized electrons. And of course, it's the delocalized electrons that are moving and carrying the charge. In an aqueous ionic compound, of course, we've taken an ionic compound, let's say sodium chloride, and dissolved it in water. So there's water molecules and lots of sodium and chloride ions. And of course, it's the ions themselves that are moving and carrying the charge, the positive sodium ions and the negative chloride ions. That is what is conducting the electric charge. In graphite, let's think back to that structure and bonding topic. Graphite, one of the allotropes of carbon that we need to know. Of course, it's layers of carbon, and each carbon atom is bonded to three others in that kind of sheet of carbon, forming a kind of a hexagonal pattern. But of course, carbon has 4 electrons in its outer shell. Only 3 of them are involved in the covalent bonding, so there's a spare electron per carbon atom. Those spare electrons are delocalized over the entire sheet. They can move and carry the charge. Finally, a molten ionic compound, it is again the ions. In a solid ionic compound, the ions can't move, and so the substance doesn't conduct electricity. But when we heat it up and melt it, that's when the ions can start to move. So whether it's molten or aqueous, it is the ions in the ionic compound that are doing the conducting. So, two key terms that we need to understand and know before we can get stuck into the rest of this topic are electrolysis and electrolyte. So, first of all, electrolysis is the process of passing an electric current through an electrolyte, and we'll define what that is in a minute, causing the ions to discharge at the electrodes, producing elements. So, let's understand that word discharge a little bit. Of course, ions are charged. They either have a positive or a negative charge. Positive metal ions and negative non-metal ions. Discharge quite simply means that they lose their charge. So something like that's an interesting little addition there. Let's get that erased. So let's start again there. So they lose their charge. Let me get the right pen. Okay, they lose their charge. Okay, so think about the sodium ion or the chloride ion. This positive sodium ion is going to lose its charge at the electrode and produce sodium metal that we uncharged. Chloride ions, similarly, going to lose their negative charge and form neutral chlorine molecules. Okay, so that's what electrolysis is. Electric current passing through electrolyte, causing the ions to discharge and produce some elements. So that term electrolyte we need to understand as well. Electrolyte is the thing that we're doing electrolysis to. Slightly more technically, it's the molten ionic compound or aqueous solution of an ionic compound used in electrolysis. Okay, so molten ionic compound or a solution of an ionic compound, and those both contain mobile ions, ions that can move. So they can conduct electricity, and those ions can move to the two electrodes and discharge, producing elements. Okay, so that's the end of the introduction. A few key terms, a little bit of a revision on structure and bonding. And now we're going to move on to the next video, which will be molten electrolysis.